Hey all, so this is the fourth problem that we have over here, which basically they want us to prove the existence of this limit, right? Using the sandwich theorem, right? Which is this one, okay? Okay, so let's do it, right? So basically the sandwich theorem, we use it when we don't know how to determine the limit of a certain function, right? Which in this case is this one, right? We don't know it, right? But we use functions to establish a comparison between the function that I don't know and a function that we know, and of course we know how to obtain the limit. Okay, so let's do it. I'm gonna do it step by step so you can understand. Okay, so basically we need to start writing this function. First of all, you need to write the sinusoidals or the cosines that you have, right? So I'm gonna write here. I'm gonna say that cosine, right, of 20x 20x divided by pi, it's gonna be between -1 and 1. And that's true, right? Because at the end, this value in this case is gonna be 20 over pi. This only affects the period of the signal, right? That's it. If we just draw this one, right? This sign, at the end, this multiplication is gonna make it more bigger, right? Or it's gonna shrink. It's gonna make it more small. So at the end, it doesn't affect because the range of the values are gonna be between 1 and -1, right? Of course, if here you multiply by 4, then you're gonna affect the amplitude of the signal, right? Of course, but here is 1, right? So we have it like that. Okay, good. Then we need to multiply by this value. So what we need to do is like to create our function step by step. So if I multiply to both sides, I'm gonna have x minus 3, and of course, sorry, this is minus cosine of 20x divided by pi x minus 3. Let me do this like here, so it's gonna be better. Okay, of course this is gonna be between 1 and -1. Okay, perfect. So now we have to introduce this limit both sides, right? So I'm gonna have the limit when x goes to 3, and I'm gonna do it here because I think we're gonna need more space, of absolute value of x minus 3, and of course this minus, right? It's gonna be limit when x goes to 3 of x minus 3 cosine 20x over pi, the limit when x goes to 3 of x minus 3, right? Perfect. So what we have to do here is that, okay, we need to understand something. For a limit to exist, right? For a limit to exist, I don't know, if for example it goes, look at this way. The limit when x goes to the left of f of x needs to be equal to the limit when x goes to 2 from the right of f to the x, which is at the end is gonna be the limit when x goes to 2 of f of x, right? This needs to occur, okay? So we can assure that the limit exists. If these limits are different, then this limit does not exist. Okay? Just so we know. Okay. Perfect. So, working over here, we're gonna have the limit of this when x goes to 3 here. It's gonna be what? It's gonna be 0, which is the limit when x goes to 3 of x minus 3 cosine of 20x pi, the limit when x goes to, sorry, of course here, sorry, in this case, if I evaluate when x goes to 3, I'm gonna have what? I'm gonna have 0 here. So at the end, this is 0. Perfect. So now that we have this, and now that we know that the limit needs to be between 0 and 0, what does it mean? It means that limit of the absolute value of x minus 3 multiplied by cosine of 20x divided by pi needs to be equal to 0. And that's how we demonstrate the existence of this limit using the sandwich theorem. Thanks, guys.